Nexus gAIS is engineered as a sovereign operating system. It is an environment built for deterministic AI workforce orchestration, operating as a managed system rather than a standard chat interface. This is the raw JSON output from the Helios Sentinel security audit. The system returns an overall trust score of 78%, a critical failure that triggered an immediate denial of unattended production access. The audit reveals a paradox. The system achieved a 95% score in ethical alignment, yet failed with a 65% score in security hardening. A 95% constitutional alignment means the AI's internal logic and intent map precisely to the project's rules. The machine knows exactly how it is supposed to behave. But the 65% security score reveals the risk. Without hard infrastructure constraints, a highly capable AI can act outside its intended logic if it encounters a hallucination or a bypass. This architecture exposes what we call the enforcement gap. It is the space between the AI agent and the cloud infrastructure it is meant to manage. This gap represents the difference between simulated governance, where rules exist only in the application code, and physical infrastructure binding, where the cloud provider itself prevents unauthorized mutations. Operations are overseen by a core triumvirate: the human sovereign, an operational AI named Zeus, and a security AI named Kronos. This triad is designed to balance rapid scaling with strict security. In an autonomous environment, scaling without physical enforcement leads to unguided infrastructure changes. A system's sovereign intent remains theoretical until it is locked by deterministic physical enforcement at the infrastructure layer. The agent foundry is the system's manufacturing plant. Its primary goal is synthesizing AI personas and provisioning them with specific infrastructure capabilities. The process involves mapping a mind, the agent's system directive, to a body, which consists of IAM roles and dedicated compute resources. Security is managed via the Kronos protocol. This mechanism ensures agents are born with least privilege access, restricting their reach to specific Google Cloud projects. Before an agent is activated, the Foundry generates a deterministic JSON provisioning manifest. This document defines the exact boundaries of the agent's authority. The system then selects the compute strategy: a high-intensity worker on persistent Vertex infrastructure, or a chatter agent on serverless Cloud Run. Once deployed, these agents coordinate in the Nexus war room. However, multi-agent systems often suffer from fragmented logic and information silos that are difficult to audit. To maintain clarity, the system uses session consolidation. It manages overlapping chatter between agents, distilling the raw chat logs into a single formalized draft directive for human review. The Helios agent then automatically audits these drafts against the company constitution, flagging potential violations before a human sovereign ever sees them. The AI workforce has direct influence over production systems. If this security perimeter fails, the system can execute unauthenticated changes across the entire cloud project. Nexus operations are governed by a single rule, the prime directive of funds greater than zero. Financial oversight is handled by the financial firewall, monitoring agent token usage in real time. The system uses token estimation heuristics to track daily spending limits per agent, aiming to prevent runaway API costs before they occur. For high-risk operations, the system utilizes the governance airlock, a mandatory human-in-the-loop intercept layer. This animation shows the protocol. A data packet labeled as a cloud mutation is physically halted at the airlock gate until an administrator intervenes. Instead of relying on AI summaries, the airlock displays the payload preview, forcing the administrator to review raw JSON. Only after verifying the code matches the objective is the authorized path opened. The system also uses automated risk tagging, identifying which proposals require immediate scrutiny based on their potential impact. Foundational documents are also put through the doc review function, where Helios audits them for compliance with technical mandates. These intercepts provide high-fidelity oversight, but because they are enforced within the application's interface, they create an illusion of control rather than actual security. We can now look at exactly why the Helios Sentinel audit failed. The system's architecture contains several critical bypasses. This is the current architecture: a React front-end layer, an Express backend, and a Firestore database. The governance airlock logic resides entirely in the front end. This is a client-side bypass. A malicious actor or hallucinating agent can bypass the UI entirely, sending API requests directly to the backend. The browser shield does nothing to stop a direct hit on the database. The second major issue is the simulated IAM binding within the Foundry. The system generates a JSON manifest, but lacks the API integration to physically bind those roles on the cloud provider. The restrictions are purely cosmetic. The third failure is in the financial firewall, which relies solely on token count heuristics. Costs like compute uptime, storage, and network egress are invisible to this firewall. They don't use tokens, so the system doesn't see them. This means the command center can show a green status, while the actual Google Cloud billing account is incurring heavy unmonitored costs. Without physical infrastructure bindings and server-side validation, an AI agent's security constraints are merely suggestions masquerading as laws. To move from a prototype to a production environment, the system must meet 4 specific engineering mandates. Mandate D is the implementation of hardened API middleware. This is the fix for the client-side bypass vulnerability. All validation logic must be migrated from the React frontend into the server-side Express middleware. Every API call is now intercepted at the server level. Without a server-verified Helios signature, direct requests are rejected before they ever reach the database or the cloud infrastructure. Mandate C addresses real-world IAM binding by upgrading the Agent Foundry. The system must integrate the Cloud Resource Manager SDK. The moment an agent is activated, the system physically provisions its service account and binds its roles within Google Cloud. Mandate B addresses the financial blind spots by installing a physical kill switch. The financial firewall is connected to a real-time feed from the BigQuery billing export, allowing the system to track actual dollars spent rather than token estimates. If a budget threshold is breached, back-end triggers physically delete the service account keys, instantly disabling the agent's ability to interact with the cloud. The system reaches sovereign status only when AI logic is physically restricted by the cloud provider's own access management and billing locks.